a very good grade for me. My name is Feng Fong, and my matrix number is 01DAD23F1001. And my part is to explain the example of application of differentiation in real life and summary and conclusion.
Hello, Assalamualaikum. My name is Salman bin Ahmad Mutazam. My matrix number is 01DAD23F1003. Today I want to present for Mathematics Engineering 2. So presentation 1. So thank you.
Good day to all. My name is Joshua Wijajun. My matrix number is 01DAD23F1006.
Good day to all. My name is Kominjan and my matrix number is 01DAD23F1013. Today I will talk about introduction of differentiation. Differentiation is a fundamental concept in calculus that deals with finding the rate at which a quantity changes. In simpler terms, it is about determining the slope or gradient of a function at any given point. The result of differentiation is a new function, called the derivative, which describes how the original function changed. It may application in various fields such as physics, engineering, economics, and more.
Today, I will be presenting the example of application of differentiation in real life and conclusion and summary. So let's start with the example of application of differentiation in real life. So you can see the picture down there have two the application of differentiation in real life cause such as optimization problems, financial analysis, engineering, physics, medicine, and economics. In physics and engineering, differentiation helps us understand motion and change. By differentiation, displacement with respect to time, we obtain velocity and acceleration. This knowledge is crucial in designing vehicles, predicting the behavior of objects in motion, and developing control system for robotics. So you can see the up picture there. They have such engineering in marine and design and maintenance, civil engineering, and the rocket. In economics, differentiation assists in maximizing profit and minimizing costs. By differentiation cost and revenue functions, we can determine the production level that maximize profit. Additionally, the concept of marginal analysis, which involves calculating the rate of change of cost or revenue, helps in optimizing decision-making processes. Besides that, in medicine, differentiation plays a vital role in modeling physiological process. By differentiating functions that describe the growth or decline of substances in the body, such as drug concentrations, we can analyze the rate of change and make informed decisions about dosage and treatment strategies. Last but not least, in computer science and data analysis, differentiation facilities machine learning algorithm and optimization techniques. It allows us to update the parameter of models based on the gradients of objective functions, leading to improved predictions and learning processes. The two picture up there is consume differentiation and calculating the rate of change of the calculation. So come to the summary and conclusion. Application of differentiation in real life such as physics, engineering, economics, biology, and more. So there is a calculus in everywhere. Differentiation is a powerful tool with practical applications in various fields. Its ability to quantify, change, analyze rate, and optimize processes make it indispensable in understanding and improving real-life phenomena. Thank you.
Moving on, we'll be going on to the questions. Below here are questions of differentiation. We'll be picking A and F. The first question. use differentiation to find expression for dy over dx. Therefore, we'll be looking at here, and we'll start to do differentiation and how do we do differentiation? We'll differentiate by moving on the power of 3 into the front, which is 2 times 3x, and the 3 minus 1. And also, from 3x squared, we'll move 2 to the front, which is 3 times 2, and the x is x power of 2 minus 1. So therefore, the answer we get is 6 squared minus 6. Later on, find the coordinates of any stationary points on the curve. To find coordinates, dy over dx must be 0. And moving on, we'll be doing the substitution method. Over here, we'll have y equals to 2x power of 3 minus 3x power of 2 as the first one. Well, the differentiated one will be the second one, which is 6x power of 2 minus 6. Later on, we will separate it by x minus 1 times 6x plus 0, which will be the third one. And after we do this, we will get that x equals to 1 and x equals to 0. Therefore, sub 1 into the question of 1, which is y equals to 2 times 1 power of 3 minus 3 times 1 power of 2. And therefore, we got the answer of y equals to negative 1. And same goes for the x when x equals to 0. Y is also equals to 0 as everything multiplied will become 0. So therefore, the stationary point coordinate we will have is 1, 1 comma negative 1, and 0 comma negative 0 comma 0. How many stationary points does the graph have? So as you have found in the question Roman 2, we have 2 stationary point coordinates. And later on, determine x-intercept and y-intercept point. To find x-intercept, y must be 0. Therefore, 2x power of 3 minus 3x power of 2 equals to 0. And we'll separate it by 2x power of 2 plus 3x bracket and bracket of x plus 0. So the x we got is x equals to 3 over 2. And later on, y-intercept, where x equals to 0, 2 times 0 power of 3 minus 3 times 0 power of 2. So we get y equals to 0. The fifth one. Determine the nature of any stationary points you found in part 2. Justify your answer. Well, from part 2, we clearly can see that the stationary point coordinate is 1, comma negative 1, and 0, comma 0. So to determine the nature of any stationary points, we will differentiate dy over dx with respect to x. And therefore, we will do it a double differentiation, where the double differentiated answer will be 12x minus 6. Later on, we'll bring back the first one. If x equals to 1, 12 times 1 power of 2 minus 6 equals to 6, which is bigger than 0. Therefore, any integer that is larger than 0 is a minimum point. So 1, comma, negative 1 is the minimum point. And if x equals to 0, 12 times 0 power of 2 minus 6 equals to negative 6, which is less than 0. Therefore, a negative integer is a maximum point. Sketch the graph of the curve, number 6, where the graph of the curve will look like this. 2 stationary points and a curve. That's all for me today. Thank you.
Hello and good evening, guys. Today I want to explain about the question for F. So number 1, y equal x3 minus 3s plus 4. So differentiate 3s 3 minus 1 minus 3s 1 minus 1. So 3s2 minus 3. So number 2, differentiate equals 0, y equal x3 minus 3s plus 4. So this is number 1. Differentiate equal 3x2 minus 3. So this is number 2. So sub s equal 1 to 1. So 1 3 minus 3 bracket 1 plus 4. So equal 1 minus 3 plus 4. So this answer is y equal 2. So sub s minus 1 to 1 minus 1 3 minus 3 uh, brackets minus 1 plus y plus 4, so sorry, plus 4 equal minus 1 plus 3 plus 4. So the answer is y equals 6. So statutory point is at 1 2 and minus 1 6. So number 3, this answer is 2 statutory point. So number 4, as intercept point y square 0, when y square 0, x3 minus 3s plus 4 equal 0, x equal minus 2.196. The intercept x bracket minus 0.196. So y-intercept point s equals 0. When s equals 0, y equal bracket 0 3 minus 3 bracket 0 plus 4, y equal 4. The intercept y are 0 4. So number 5, differentiate dy dx with respect to x. d 2y equal dx 2 equal 6x, x equal 1 6 bracket 1 equal 6 0. So 1 2 is a maximum point, x equal negative 1 6 bracket negative 1. So the answer is negative 6. So bracket negative 1 6 is a maximum point. So number 4 is okay. So the answer is 1 2 3 4 5. So this final answer number 6. Okay, thank you.